I'm Simon McManus. I'm an engineering manager at Trainline, and I am here to talk to you about tracking repository health at scale. So at Trainline, I look after the web platform. I'm going to start with a few questions. How healthy is your estate? To know the answer, you need to know A, what you mean by health, and you need to know what you mean by your estate. At what point would you know it changed? If it got worse, what's your feedback loop? How quickly would you find out it's deteriorated? So at Trainline, we've been looking at this, how to track some of this stuff and how we can improve our notifications. Apologies for this poor visual design, but this is meant to be a Slack notification, and we now get a notification to say something's changed if it's got worse, and we can change the behavior engineers get on our platform based on the health. So if things are unhealthy, we can ask them to make it healthy before they continue contributing to it. Obviously, this is completely fictional. LDX3 repositories are wonderfully healthy, I'm sure. Okay, one last question before we get into details. How big is your estate? The reason I ask this, this graph is about a year and a half worth of data, and it shows how we've been tracking our repositories over that year and a half. We started just with the repositories on our service catalog, which was around 30, which is before this graph started. And as we found more repositories, this graph just keeps growing. By tracking them, there's more value in tracking them, so we find more and more. All of these repositories are contributing to the code in production. So it just shows the more you look, and actually, rather than thinking about a service level, at a repository level, you realize there's a lot more there. And some of these are monorepos. These aren't just single repositories. Some of them contain many, many packages. So you might be wondering why we need 160 repositories at Trainline just for our website. I just want to talk about what we do with the web at Trainline just to try and make this make sense. On the top half here, we've kind of got our business-to-customer offering, and the bottom half is more our business-to-business offering. So we've got our booking flow. I hope you all used it to book your train tickets here, and you're very familiar with it. But essentially, pick an origin, pick a destination, go through, purchase your ticket, and get to the end. We also have landing pages. We have a home page. We have it available in multiple languages. We also have somewhere between 4 and 5 million other landing pages. So these are highly optimized pages for specific use cases. So if you search for any station, we want to be right at the top result, or the top organic result in Google. We have origin-destination pairs. So if you're looking to go from London to Manchester, London to Edinburgh, if you search that, we want to be the top result. And this is for SEO reasons, geo reasons. We want to be where you come to buy your train tickets, and we want to optimize that experience. So when you land on that page, making it as optimum as possible to go through and buy your ticket. We also have a customer area. So this is like once you bought the ticket, you might want to change the ticket. You might want to log into your account and see the details. That's also consumed by quite a lot of our app. So if you go to the My Account area in the app, you'll end up in the website, just in a web view, essentially. On the Trainline business, so this is the business-to-business stuff now. So a business can come to us, get an account, and all of their employees can then buy train tickets through us. We've got white label offerings, so people can essentially provide the same service that we do, but skin it differently. So some train companies will actually be using our platform underneath the hood. And we also have affiliate widgets, which allows people to embed the search widget in their website and then go either into a white label or into a booking flow. About 4 years ago, this was roughly how we had the business set up as well for delivery. So these were 6 independent clusters. The things were completely independent, and they didn't really overlap. There wasn't much connection between them. About 3.5 years ago, we moved to a horizontal and vertical model, and that's where the web platform came in. So now we've got a platform along the bottom, and we're responsible for the health, for maintaining high quality and things like that. And then those units are still there. They're slightly smaller. They're not so concerned about the ownership. They're more concerned about the business delivery and delivering features on top. And we need to ensure that the code base remains in a good state while they deliver the business value. So just to look at some of the changes that introduced, we went from engineers being specialists in their particular cluster to engineers needing to be generalists. They needed to be able to jump to any part of that stack to be able to deliver the value. Before we could have loose conformance, it was probably React in most of the repositories, but the way you deliver to production, the pipelines, all of those things would be vastly different, even the dependencies that are used. Now in platform, we want to have tighter conformance. We want things to align. We don't want people to have to relearn a repository every time they change to a different repository. We achieved that through, we had multiple communities in the old model. So each area had their own web community that decided the best practice, whereas we wanted to have one web community that made those decisions, decided what good looks like, and comes to an agreement. A cluster previously might have 3 to 10 repositories it looks after, and it would do a manual health check, a manual list. Each team would take one every quarter, go through a manual health check, validate if things are there and they're correct, and if they're not, they do the work in that quarter to bring that single repository up to a healthy standard. When you're looking at across 160 repositories and a relatively small team, that approach doesn't scale. So what I'm going to be talking today is what we came up with and how we're trying to manage that and ensure we maintain health at that kind of scale. Before we can get into the details, we need to talk about health. What is health? So we've got some platform principles. So these aren't specific to the web platform, just general principles. I'm just going to talk you through them now. We want our platform to be secure. You should trust us with your data. We want our platform to be productive. It should be easy to release, up-to-date, and self-service. Engineers shouldn't need to come and talk to the platform team to be able to release their changes and know how to operate on the platform. We want it to be consistent. And we want it to be consistent in 2 ways. We want consistency for our engineers so that they can freely move between repositories, but we also want it consistent for our users. A button should look like the same button all across the estate. The search widget should be consistent all across the estate. And we want it to be conformant. So our community is deciding what good looks like. This is how we measure how well we align with that definition of good and how we're progressing towards it. So that's general health. This talk is more about repository health. What is repository health? So the health of a system can cover a lot of different things. These are all very good and important measures of system health. So uptime, latency, error rates, throughput, DORA metrics, static code analysis, analytics, business metrics, test coverage, core web vitals, build systems, build status and time. These are all good measures. This is not what I'm talking about with repository health. These are more about when the system is running. The way I often think about it is repository health is when the code is resting, when it's not being run. When it's sitting there, nothing is changing about the code. There's a whole ecosystem that's evolving around that code while it's not being touched. So different security vulnerabilities will get introduced. Node versions will go out of support and start introducing new security vulnerabilities. Best practices, as defined by our community, will evolve and change. How well are we keeping up with those things? So I'm just going to talk you through some of the checks, just to be a bit more specific here and get into a bit more detail. So as we're a web platform, our main runtime is Node. We have a check that just checks the Node version. Node has the idea of LTS. If it's within LTS, it will receive security fixes. So we always want to be running a version of Node that's within LTS. It looks to see if the repository is running a node within LTS. If it doesn't, it would fail this check. We have a versions check. So we look at the package lock file to see what dependencies are being installed as part of this repository. We have an internal rule that we want to be within 2 major versions of the latest release. So if any of the dependencies are more than 2 versions out, this check would fail. We have a permissions check. This is mostly about GitHub permissions and how it's configured. So we want everyone to have a consistent experience, whichever repository they land on. So it should always require pull requests. It should require the same number of reviews. You shouldn't be able to commit directly to master. Admin should be managed via groups and no individual members added to be admin so that they can do extra things. Everything should be managed through groups, essentially. We define the rules programmatically and we check them against every single repository. We do a security audit. We look for high critical vulnerabilities. Any of those found, it would fail that check. we have a capabilities check. Capabilities is things like our design system. Is it using the design system? Is it using our shareable components? Is it using our accessibility testing suite? Is it using our type system? This allows us to check that we're moving towards that good vision that we've got of the future. We also have restricted packages. So as a community, we decided that we don't want to use Moment.js anymore, and we want to move towards Day.js. So this is looking for those things. Are we still using Moment.js in a repository? In which case, it would fail the check. So we have various initiatives. Sometimes we run them internally within the platform team. Sometimes the community leads them. Things like rolling out Dependabot, getting it turned on for all of our repositories. Also things like migrating to the cloud. These checks allow us to see how far we are along that journey across the entire estate.
If you're enjoying this, then Lead Dev's got loads more to offer and there's tons to explore.
So the reason I love Lead Dev so much is they've got such a range of content on so many different topics in the world of engineering, leadership, and management.
So Lead Dev helped a lot on building my own career, right? And it's great to also see how it's helping the new generation as well.
Make sure to sign up and join us at leaddev.com.
So what I've shown you there is a fairly small subset. We don't run all the checks for all the repositories, and I'll get into those details in a little bit. But I think it's just worth highlighting. The definition of health will evolve, and that's a good thing. You're going to learn more about what it is to be healthy. You're going to get a better understanding. You're going to get better at programmatically detecting what it is to be healthy. That evolution is a good thing, and you shouldn't worry about it. You should celebrate that evolution. Ultimately, this is about communication. So who are we trying to communicate to? We're communicating upwards, all the way to the CTO, to try and communicate the size of our estate, the areas that need focus, the areas that don't need so much focus. Internally, within the web platform and the web platform leadership, we'll use it to prioritize our work. We can see trends, we can identify where things are getting worse or they're getting better, and we can focus our work and the work of the community to address areas that need it. It's also really useful for communicating to the engineers contributing to our repositories. So we label repositories as being in a particular state, and we ask engineers to check the repository state before they start contributing to it, before they start estimating it, so they can understand if there's going to be additional work. We're now at the point where we're almost able to actually stop them committing to repositories that are in poor health, and we ask them that they have to improve the health before they start adding new features. And it's a forcing function. If it's important enough as a repository, it naturally makes the health better versus moving it to a different state that we'll talk about. So to communicate, we start with a score. We need to work out a simple score to say how good the repository is. Each check can return 4 states. It can give a pass, a warning. Warnings aren't too bad. It can fail, and it can be indeterminate. If you can't even tell if it's failing, that's kind of really bad. So we calculate the score just by taking the number of passes and warnings, divided by the total checks that were run for that repository, times by 100, gives us a nice simple percentage. This is a fairly crude mechanism. At least every other week, we have a conversation around should we add weighting into this, so that certain checks have more weight than others. So far, we've used this. It's nice and transparent, but I imagine it will evolve at some point in the future. OK, once we've got a score, we can start making it a little bit more visual. So what we're looking to do here is create a RAG board, red, amber, green, to give a really distant view of what the state of everything is. So I've mentioned the lock state already. We determine that by anything that's under 40% threshold. So anything below 40% would be considered in the locked state. Anything above 60% would be considered healthy. And stuff that's in the middle, we consider risky. Again, this is a fairly crude mechanism, and it's going to evolve. Those thresholds will change, and that's not a bad thing. You're going to learn more. It's actually all right if the thresholds go down. You might introduce a whole load of checks which fail at first, and as you improve them, it will get better, but you'd reduce the thresholds there. It seems very simple, but actually what you're looking for is a multicolored board. You don't want everything red. If everything's red, nothing's a priority. If everything's green, nothing's a priority. You want a variety of colors so that you can see what areas you need to be focusing on and prioritizing. Now, you might think, healthy, is the state you want on all of your repositories. And it is, but it's very, very expensive to maintain lots of repositories in a healthy state. So the one thing that you can do that's better than maintaining them all in a healthy state is move them to archived, and then you don't worry about maintaining them. But for that, you need to understand where the business value is. So we're always trying to identify what's healthy and what should be maintained in a healthy state. If there's not business value there, we can move it to an archived state and speed that process up. And that allows us to reduce the size of the estate, then maintain the important parts of the estate to a higher standard. Okay, I'm going to talk a little bit about how all this works. There's a QR code on the screen. That goes to a blog post which gives you a more detailed view of how all this fits together. But I'll still give you a quick overview. It's not really anything clever we're doing here. It's got no databases, no big systems. It's essentially an array of JSON objects that list all of our repositories with a small amount of metadata about each of them. Once a day, we go through that list. We fetch a small piece of metadata from each repository, so things like the package lock file, npmrc file. We look at the service catalog to identify what type of repository it is. We don't need to run the same checks against a component library that we do against an API or a web interface. Once we know that, we can run the appropriate checks. We store the results in JSON, calculating the result based on what I just told you. We store all the metadata we generate as well in those JSON files. From that JSON file, we generate a static HTML file, and we push it all back up to GitHub pages. We don't just keep the latest version, we also track it historically. So we've had this running for about a year and a half, and in that year and a half, we've got a JSON file and a HTML file for every single day it's run. And that allows us to programmatically interrogate it, and like the report that you saw earlier around the estate size, that was because we've got that historic data. At that point, we can report changes to Slack, so we can see if the status has changed, got better or worse. We can report that into Slack. We've got a dedicated channel where we can keep an eye on those things. We also push that data for key repositories into Plandeck. So Plandeck is our tool we use for DORA metrics, and it allows us to see how repository health relates to our productivity as a company. If we improve the health of a particular repository, do we see that we become more productive when working on that repository? Okay, let's have a look at the dashboard. I have to say, this is not real data you're about to see. This is a very fake dashboard, so don't read too much into it. So what you can see here, on the bottom half, we have the individual repositories. There's not 160 repositories here, there's 14, which makes it a bit easier to show you on a big screen. But you've got the individual repository scores down here, and at the top, you've got the overview information. On the left-hand side, the overall score, and on a per initiative basis. So if we have a little look, again, these are not our repository names. In the bottom left, you've got a little icon which just shows the owning team, so you know who to go and speak to if you do need to speak about more details. For each repository, you can see how many things are passing, warning, failing, or indeterminate. And the other thing that you can see here is these top 2 repositories are marked as core repositories. These are repositories that we think aligns with our vision and the future state we want to move towards, or there's P1 applications or direct dependencies of our P1 applications. Essentially, these are the things we want to keep to an even higher standard. These are really important repositories that we want to maintain to the highest standard. So up at the top there, we track those 2 things independently. So these is just an average of all the repositories. So the one on the right is all repositories, and that's the average percentage that we've got. It also shows us the count and the trend. So on the right, it's trending flat. Core applications, we can see here there's 5 of them, and it's trending down. If I came in the morning and saw this, I'd dig into it a little bit to understand why we're trending down. It might just be we've adjusted our thresholds, but it suggests there's probably something not quite right there. And then for each check, we can see the individual status of that check. So I've taken the names of the checks away, but here you can see check 3. We've not made much progress on that. So whatever that is needs a lot more work. It might have been a new check. It might be fine. But check 9 and 10, we can see there's some warnings, but we've actually rolled it out across the majority of our estate. Maybe not all the estate, but certainly across the core apps in the estate. Okay, I'm going to zoom in a little bit, but this is kind of the more detailed view. So when an engineer is told they can't commit to a repository because they need to improve the health, this is the view they get sent to say, this is how you can improve the health. Again, very fictional repository. But so each check that's failing, it gives you an explicit fix. It tries to make it as easy for you to action as possible. So in this case, it's missing our design system, it's missing our shared component library, it's not using our type system, our browser testing, or our accessibility testing. So to fix this check, an engineer would have to use and consume all of those things in that repository. So we went from a situation where we ran one health check on one repository in one team in a quarter, to now we run all of these checks, the relevant ones, across all of our repositories at least once a day, often multiple times a day. And we're also moving to the point where we can actually run it against PRs, so we can stop people even introducing regressions. So how are we using this? It's a really useful tool for tracking trends. I've not shown it, but all of this stuff is available on graphs, and you can see over time what's getting better, what's getting worse. At the start of each quarter, as we're planning that quarter, I'll look at that with the leadership, and we will decide if there's areas we need to focus on. There's even been times on a daily basis where we see that we've made a slight mistake and we've broken all the permissions, let's fix that quickly. It's a really fast response mechanism that we get from it. I think we covered this already. It's a good way of communicating risk, both to senior management and to engineers that are contributing to the repositories. It's really good for handovers. If a team's handing it over from one team to another, they can say, these are the areas that need work over the next 6 months. It's not a blind handover where you suddenly get a big surprise. It's very explicit what the state of it is. One really nice use case we saw was people taking before and after screenshots. So they'd be working on a feature. They'd take a screenshot of a locked state or maybe a risky state before they start. They'd deliver their feature, but they'd also improve the health while they were there. So they'd then take another screenshot afterwards. And then they can share that in the Slack channel. And we saw people posting it. And it's a really nice mechanism to show to your manager that, yes, I delivered the feature, I did my job, but I also did this additional thing to bring the health up and improve the score overall. And that can be used in things like promo packs, end-of-year reviews, just to demonstrate you're going a bit further and you're doing the right thing to keep the platform in a good state. So future plans, we use a tech radar. We want to kind of integrate that. So if it's on the tech radar saying don't use it, the health check will tell you not to use it as well, and we can quite easily automate that. This is one of my little pet projects. I want to have ownership leaderboards all around the office. So any team that owns a repository, they can see how they're doing compared to the other teams around the office. Are you maintaining it to a good standard compared to the rest of the team? Trying to gamify it at director level, so the director sees how their team's doing at maintaining their health. And I think the PR integrations is really the thing that's going to make a difference here as well. There's a carrot and there's a stick. So I mentioned people sharing screenshots. We can automate that. We can make it so in every PR, we see what you've done to the health. If you make it worse, we block it. If you make it better, we'll say thank you. We'll say thank you for making it better. And this is what you've done to make it better, and that's a nice opportunity to demonstrate the value that you're adding. But then we've also got the other extreme, which is blocking, which is the stick that we don't want to use, but it allows us to say that you can't just let something go into a bad state. You need to improve the health with it. If it provides enough business value to justify doing that, we maintain it to a high standard. If we can't justify that extra time, that's fine. We move it to an archived state, and we don't maintain it. And it's given us a really nice forcing function to ensure we do maintain the right things to a high standard. The things that aren't providing value, we don't worry about so much. Okay, so conclusions. We have a better view of our estate now than ever before, and we can measure the health programmatically. Real data is guiding us to focus our efforts where they matter the most. Teams are empowered to own and improve the systems they depend upon. We're building a platform where quality and delivery go hand in hand. Delivery is great, but sustainable delivery is so much better. Thank you very much for listening. I'm Simon McManus. You can find blog posts, links, and you'll find me on Blue Sky at the URL above. Thank you very much.